Hello and welcome to USGS Corecast. My name is Jessica Robertson and I will be your host today. This August, American and Canadian scientists will put on their cold weather gear and head north on a collaborative expedition to map the Arctic seafloor. The data they gather will help define the outer limits of the continental shelf in the Arctic Ocean and ultimately define both countries' sovereign rights over minerals, petroleum, clams, coral, and more. Today we are joined by USGS scientists Debbie Hutchinson, Brian Edwards, and Jonathan Childs to discuss this upcoming mission, past expeditions, and the overall project. Thank you all for joining us today.
Oh, it's my pleasure to be here.
Thanks for having us.
My great pleasure to be part of this conversation.
So John, can you first tell us why are you traveling to the Arctic to map the seafloor?
Well, Jessica, we've been collaborating with Canada for the past 3 years to map and define the outer limits of our continental shelf in the Arctic Ocean. This will ultimately define our sovereign rights over the natural resources of the seabed and the subsea floor. As you previously mentioned, these rights include control over the development and preservation of minerals, petroleum, and the sedentary organisms such as clams and crabs and coral that may inhabit the seafloor.
And Brian, can you tell us a little bit more about the expedition plans and when you'll set sail?
Our team will be leaving from Dutch Harbor, Alaska, which is out on the Aleutian Chain, on August 2nd, aboard the United States Coast Guard cutter Healy. We'll be transiting north. It'll take about 5 days to get through the Bering Straits and then to meet up with the Canadian Coast Guard cutter, the Louis S. St. Laurent, somewhere offshore of Prudhoe Bay in Alaska. The Louis is sailing from Kugluktuk in the First Nation state of Nunavut, Canada. And after we meet in the offshore, we will transfer some personnel, and then we will begin collecting data, which will take approximately 4 weeks to complete the mission.
So Debbie, don't we already know the limits of our continental shelf? Why are you conducting this research?
Well, according to the United Nations Convention on the Law of the Sea, every coastal nation automatically receives the continental shelf out to 200 nautical miles or to a maritime boundary. The convention also states that a nation is entitled to additional continental shelf if it meets certain criteria. And that portion of the continental shelf beyond 200 nautical miles is commonly known as the extended continental shelf. In this upcoming expedition, we're collecting data that will help us determine if we meet those criteria and can define an extended continental shelf beyond 200 nautical miles. We don't know that now.
And why are we working with Canada on this expedition? What is the benefit of the joint effort?
Well, we're working with Canada because the extended continental shelf of each of our countries overlaps. Imagine going north from Alaska and west from the Canadian Arctic Islands. And there's a big overlap in the Canada Basin portion of the Arctic Ocean. It makes sense for us to work together in these remote and challenging environments, and it makes sense to work with the same data sets.
So John, how long has the U.S. been conducting research in the Arctic so far?
This is the third year of our 2 icebreaker work with Canada. We started in 2008. Before that, the U.S. was independently collecting data with the U.S. icebreaker Healy in the Arctic, starting back in 2003 to address extended continental shelf requirements.
And John, how much longer will it take to collect the data necessary to determine if we are entitled to an extended continental shelf? What plans do you have for future research?
2010 is our last year working in the Canada Basin north of Alaska. In 2011, we'll move further north to collect data together with Canada in the area far north of the Canada Basin around a seafloor feature called the Alpha Ridge. The entire United States Extended Continental Shelf program will probably last another 8 or more years and will cover most of the U.S. continental and island margins.
John, is the Arctic the only area where the U.S. may have an extended continental shelf? If there are other places, have we started mapping those areas yet?
The U.S. has extended continental shelf on most of its coastal margins. A federal interagency task force has identified areas in the Bering Sea, the Gulf of Mexico, the Atlantic coast, and the Western Pacific, where an extended continental shelf can almost certainly be identified, as it is in the Arctic. There are several other areas in the Pacific that are less certain, and we have much more work yet there to do.
Debbie, so what's it like working in such a cold environment? Do you ever run into difficulties or challenges while working in these ice conditions?
Well, I've spent the last 2 summers in the ice, and modern icebreakers like Healy and Louie have all the modern conveniences and creature comforts one might want, maybe excepting good internet. But the cold's extremely hard on parts of our gear that are exposed on the deck of the ship or that are operating in the very cold, almost freezing water. In 2008, we had several instances where one icebreaker had to help free the other from being stuck in the ice. In another instance, Louie had to shut down all power for electrical repairs. I think it was after about 2 hours everybody was putting on more layers of clothes to stay warm inside. It cools down pretty quickly. Working in these remote, cold environments requires constant vigilance and care.
Brian, what types of data are you collecting on Healy, and can you give us an overview of some of the research instruments and techniques you're using?
Sure, I'd be happy to do that. We will be collecting 2 primary types of data. One will be making detailed measurements of the depth of the seafloor. We refer to that as high-resolution bathymetry. The Healy has a very sophisticated echo sounder system which emits a sound pulse or a ping into the water that transmits through the water column and then bounces off of the seafloor, and that energy is returned back to the ship as an acoustic wave. The time it takes for that echo to move from the ship to the seafloor and back to the ship is recorded very accurately and is used to calculate the seafloor depth. The second set of samples or data that we're collecting is recovering physical samples underneath the ship that will provide an insight into the geology or makeup of the seafloor.
And John, what about research on the Canadian ship? Can you tell us about that?
The Canadian ship, the Louis Saint Laurent, provides a multi-channel seismic reflection system. And this system helps image the sediments and geologic structure of the subsea floor.
Debbie, who else is involved in this research, and what exactly is the USGS role?
The U.S. effort in this expedition is being coordinated by the U.S. Extended Continental Shelf Task Force. This is an interagency group chaired by the U.S. Department of State. The USGS is the lead science agency for the U.S. in this year's expedition and has held either the lead or assistant roles in the past years. NOAA sometimes also leads and assists in the U.S. data collection efforts. Our Canadian colleagues come from Natural Resources Canada, the Department of Fisheries and Oceans, the Department of Foreign Affairs and International Trade, and of course the Canadian Coast Guard.
Thank you all for joining us today, and thank you to all of our listeners. You can learn more about this mission and get a glimpse of life in the Arctic by visiting continentalshelf.gov. There you can find background materials, follow a near real-time blog authored by those on board the upcoming mission, view photographs and video, and more. Corecast is a product of the U.S. Geological Survey, Department of the Interior.